Dear students, I myself is Dr. Rajeshekar Reddy, Assistant Professor of Mathematics, Government First Grade College, Pavagada. Now we discuss third semester BCA Mathematics. In this, we go for Unit 1 Matrices. In the previous sessions, we have learned the basics in matrices, how to find determinant of a matrix and how to find adjoint of a matrix, then finding inverse of a matrix, and a little bit about the calculations in matrices. Using the matrices, we can find the solutions of linear equations. In the previous session, we discussed about system of linear equations. For system of linear equations, we can find the solution set by using different methods. So in this session, the easiest method, the efficient method, the good method for finding solutions of linear equations with arbitrary number of constants we can discuss, that is Crammer's rule. This Crammer's rule is applicable only the number of unknowns is equals to the number of given linear equations. Suppose the given system of linear equations, there are two unknowns, they should give two equations. If there are three unknowns, they should give three equations. That means the same number of equations as unknowns. Number of equations is equals to number of unknowns. If this satisfies, the condition satisfies, we can apply Crammer's rule. Crammer's rule will give us only one solution, unique solution to the system of equations if exist, otherwise we don't get the solution. So remember that Crammer's rule is the best and easiest method to find the solution of linear equations. But to apply this Crammer's rule, there is one condition. The number of unknowns in the system of equations is equals to the number of equations. Number of unknowns is equals to number of equations. This satisfies, the condition satisfies, we can apply the Crammer's rule. In the Crammer's rule, to solve the system of linear equations, first the system can be written as matrix form, that is Ax is equals to B form. Let us consider one example. So in this Crammer's rule, to find out the unknowns x, y, z, x is equals to, we take the formula delta 1 divided by delta, and y is equals to delta 2 divided by delta, z is equals to delta 3 divided by delta. Here what is delta 1, delta 2, delta 3 and delta? Delta is nothing but the determinant of coefficient matrix. In the given system of equations, if you write in matrix form Ax is equals to B, the matrix A, first one A is called coefficient matrix, X is called unknown matrix, B is called constant matrix. So here delta represents the determinant of coefficient matrix. Delta is determinant of coefficient matrix. Then what is delta 1? Delta 1 is the determinant of in the coefficient matrix, the first column is replaced by constant matrix. The first column is replaced by the constant matrix. Okay. Delta 2 is also the determinant of in coefficient matrix, second column is eliminated by right hand side constants, constant matrix elements. Like that, delta 3 is also determinant of coefficient matrix, but in the coefficient matrix the third column is eliminated by the elements in constant matrix. Okay. So x is delta 1 divided by delta. y is delta 2 divided by delta, z is delta 3 divided by delta. What is delta? Delta is the determinant of coefficient matrix. Delta 1 is, it is also a determinant. While finding the determinant, the matrix A, in the matrix A, the first column is replaced. First column is replaced by right hand side constants. That means B, constant matrix elements. Delta 2, it is also the determinant of the coefficient matrix, but in the coefficient matrix, second column is replaced by constant matrix elements. In a similar manner, delta 3 is also determinant of the coefficient matrix if the third column is replaced by coefficient matrix. Based on these formulae, we can find the solution set x, y, z. For example, if you take fifth one, solve the system of equations by Crammer's rule. 2x minus 5 plus 4z is equals to 12. 3x plus 2y plus z is equals to 10. X plus y plus z is equals to 6. First, we have to check whether the Crammer's rule is applicable or not. Already in our mind, there will be a condition. There would be a condition. What is that condition? Crammer's rule is applicable only when the number of unknowns is equals to number of equations. So in the given system of equations, how many unknowns are there? X, y, z. There are 3 unknowns. How many equations are there? First equation, second equation, third equation. There are 3 equations. So here condition satisfying. Number of unknowns is equals to number of equations. Next, while solving the system of equations by Crammer's rule, keep the constants always right hand side. Even though constant free from variable, even the constant is nothing but it is free from variable. Only number only appears. Do not contain, the term do not contain any variable, is known as constant. So such constant, even though left hand side appears, so shift into right hand side. LHS, in left hand side constant appears, you shift into right hand side. So keep all variables one side and constant other side. First you frame the system of equations like that. After framing the system of equations, variables one side, constant one side, then you write the system of equations in the form Ax is equals to B, matrix notation form. Ax is equals to B form. In Ax is equals to B form, A represents coefficient matrix, X denotes unknown matrix, B denotes RHS, constants matrix, constant matrix. So in this example, A, the coefficient matrix is first row 2, minus 1, 4. Second row 3, 2, 1. Third row 1, 1, 1. So 2 minus 1, 4, 3, 2, 1, 1, 1, 1. That is coefficient matrix. Next, unknown matrix. Capital X is equals to unknowns X, Y, Z. It is a column matrix. Next, B, right hand side constants 12, 10, 6. This is also a column matrix, contains only one column, 3 rows, 12 one row, 10 another row, 6 last row. So after writing the given system of equations in the form Ax is equals to B, we have to measure delta first. Delta is nothing but determinant of the coefficient matrix. Determinant of the coefficient matrix. So determinant of 2, minus 1, 4, 3, 2, 1, 1, 1, 1. In the previous sessions, we have learned to find to find determinant of the matrix A. So to find the determinant of matrix A, first you take the symbols plus, minus, plus. So 2 into eliminating the row containing 2, the column containing 2. So 2 into 2 minus 1. Next, minus of minus plus 1 into eliminating the row contains minus 1, the column contains minus 1. That means 3 minus 1. Next, plus 4 into 3 minus 1. So it becomes delta becomes 8. So it is the determinant of the coefficient matrix. Next we have to calculate delta 1. So delta 1 is also a determinant of the matrix if the first column of the coefficient matrix eliminated, replaced by the constant matrix B. So to find out delta 1, the first column of the coefficient matrix is eliminated by constant matrix, not eliminated, replaced by coefficient matrix. That means determinant of first column is 12, 10, 6. Second column is minus 1, 2, 1. Third column 4, 1, 1. That's why this one is equals to 12 into 2 minus 1 plus 1 into 10 minus 6 plus 4 into 10 minus 12 becomes 8. Next we take delta 2. While measuring delta 2, the second column of the coefficient matrix, should be replaced by the constant matrix. That's why determinant of 2, 12, 4, 3, 10, 1, 1, 6, 1. So calculating this determinant, we get the value is 16. Like that, we measure delta 3. Delta 3 is the determinant of the coefficient matrix when the third column is replaced by constant matrix. That is determinant of 2 minus 1, 12, 3, 2, 10, 1, 1, 6. So calculating this determinant becomes 24. Then x is equals to delta 1 divided by delta. So delta 1 we got 8 divided by 8, 1. Y delta 2 divided by delta, that is 16 divided by 8 is equals to 2. Z is equals to delta 3 divided by delta, that is 24 divided by 8 is equals to 3. So then the solution set x is equals to 1, 2, 3. X value 1, y value 2, z value 3. So in Crammer's rule, you should remember one condition. Crammer's rule to apply, what condition should remember? The number of unknowns is equals to the number of equations. In Crammer's rule, solution exists, it gives only one solution. That's why in the first question Crammer's rule exists, then it gives how many number of solutions? Only one. If Crammer's rule does not exist, then it gives how many number of solutions? No solutions. Rule exist ಆಗ್ತಿಲ್ಲ ಇಲ್ಲಿ. That's why solution ಅಂತೂ ಬರೋದೇ ಇಲ್ಲ. That's why it doesn't contain any solution. The third one is main point is applicable only the number of unknowns is equals to number of constants. The coefficient matrix of system of linear equations is singular. Singular means determinant is 0. Whenever the determinant is 0, the Cramer's rule is not applicable. Remembering these points, we can solve the system of linear equations in very easy method, in easy way by using Cramer's rule.